Hello and welcome back. My name is Kirsten McMillan with the Climate Risk Institute. In this module, we'll be talking about performance response considerations for water infrastructure. In previous sessions, you've learned some of the following definitions and concepts related to climate risk and walked through some examples, including sensitivity, adaptive capacity, and vulnerability. The definition of a performance response consideration is the change, positive or negative, in condition or function of a system that is traceable to a specific stressor event. So let's take the example of a climate hazard like extreme heat, which would be the stressor event. If we're thinking about the performance response of the material, this will be able to respond more positively to the stressor if it has already been designed for fluctuating temperature and has been well maintained. If it has not been well maintained or was not designed to withstand these types of temperatures, you can see how the condition or function would deteriorate based on the extreme heat event. So we can consider performance response considerations as something that is a driver or root cause of a sensitivity. So we understand that things can break or underperform for a number of different reasons. So we've broken this into four main categories that will be discussed in this module, including design and functionality, operations and maintenance, emergency response, and policy. We'll go through a few examples. So for design and functionality, some of the example for performance response criteria that the climate may affect are things like the load carrying capacity, fatigue, cracking and deterioration, the type of equipment that has been selected, and the material, the sizing, and things like modeling inputs that would have gone into the design. For operations and maintenance, we could look at criteria like the capacity to conduct routine or planned maintenance, the availability of equipment, how often components are being replaced, occupational safety, and things like accessibility to sites. For emergency response, we could look at criteria like what types of procedures are already in place before an emergency, what resources are available for an emergency response, so that can include things like the people and also the equipment, and then finally, is the site accessible or not in the case of an emergency. Policy is kind of a unique example as it builds upon those other criteria like design, operations and maintenance, and emergency response. So things like codes, guidelines, standards, procedures, and things like land use plan will all help to inform those other decisions. In the following slides, we're going to walk through three different example components. So these is a very simplified system, but we're going to look broadly at the dam and reservoir. We're going to look at access, which could include things like roads and culverts and how the site is connected to the surrounding community. And then energy, generation, and distribution, so things like the turbines, powerhouse, and transmission lines. So first, let's look at access, and then think about design and functionality as a performance response indicator. So something like asphalt, if it's able to take on greater heat absorption, so after an extreme temperature event, the asphalt will become softer, and then if you have heavier vehicles traveling on this, this can cause greater damage. So when you're thinking about the design of this road, has it been prepared to handle these extreme heat or not? And then how will that play into the amount of impact experience? Think about an event like extreme precipitation. If this road was selected to be a dirt road, in an extreme precipitation event, there could be a lot more erosion than something like asphalt. And then you can see as well, we have this culvert here. Was this sized properly during the design process? Is it considering an extreme event or something that may happen more frequently? Those questions in the design process will really change how the system will perform in an extreme event. So this road could become completely impassable if things like the culverts were not sized properly. Consider some of the design performance response considerations that apply to the dam and reservoir. So when we're thinking about sizing of the spillways or the dam crest, we can think about what went into the design process and whether or not some of these extreme events were considered. We can also think about things like sedimentation. So if there's a high amount of sedimentation upstream, you can lose some of the storage capacity. So even if the system was sized for an extreme event, if sedimentation wasn't considered and the reservoir is only able to hold, let's say 50% of what the design intended, you can see how a high precipitation event or very high water levels could be very different depending on this design and functionality consideration. We can also think about the type of material that was used. So in a very high temperature event, or temperatures that fluctuate from very cold to very hot, this can result in cracking. So this could be addressed earlier on in the design process to see what types of temperatures the system may experience, and also thinking during construction to plan out whether or not something is placed in an extreme event or if you have to take a little bit longer so that that cracking doesn't occur. Continuing with design and functionality, but for the energy generation and distribution components, we can think about this building here and whether or not it was designed to withstand high precipitation events and moisture. So if all of the components inside could be dramatically damaged with a small rainfall event. At a broader level, you can think about the site selection. So before anything was constructed, is this building located in a floodplain and is therefore much more susceptible to flooding? In the design and stage of the process, you could move the building over and limit a lot of those considerations. Thinking about extreme heat, you can see that connectivity can be greatly decreased in transmission lines in extreme heat, but there's also ways to work around this during the design process. Thinking about wind, there can be high amounts of damage to transmission lines in high winds, so making sure that there's appropriate footing and other infrastructure in place so that these are not knocked down in high wind events. The next design response consideration that we'll look at is operations and maintenance. So look at this access road here. You can have things like potholes that appear on the road, and if you have good operations and maintenance in place, these can be frequently repaired so they don't become a problem. However, if there's a lot of different holes along the road and they become larger and larger without any maintenance performed, you can see how in an emergency like a flood event, this could really deteriorate the system and actually prevent access. You can also look at things like culverts. So when culverts are frequently cleaned out, then they're able to perform as they were designed to do. However, if you have a lot of debris, this can result in clogging. So even if this culvert was designed to withstand the biggest storm possible, if there's a lot of debris that's blocking it, then it's not going to react well to a climate extreme. So we can think about the type of operations and maintenance procedures that are required to make sure that they're able to perform as intended. Continuing with operations and maintenance and the dam and reservoir system, we can continue to talk about sedimentation, which is similar to the concept of debris in the culvert. Even if this system was designed to withstand sedimentation or perhaps was oversized, you still need to have procedures in place to clear this out frequently. So this ties in the relation between the design and functionality and the operations and maintenance and how they need to work together to make sure that the system is able to withstand some of these extreme events. Also thinking about temperature. So as you mentioned, you can have cracking in some of the concrete. If this is something that can be frequently repaired or at least monitored, then you'll be better able to withstand some of these impacts. Whereas if you don't realize that some of these systems have cracked during an extreme heat event because no one has been through to monitor the conditions, you could experience much higher levels of cracking or even a breakdown of the system because you just weren't aware of the deterioration that had taken place. The concept of monitoring as it relates to operations and maintenance is also very important for the energy generation and distribution system. So for example, are you able to recognize that there's higher water levels and therefore the system may need to respond differently? Like for example, having the turbines operating at different speeds or having staff available to respond to the events. We can also look at the transmission lines. So we know when the area surrounding transmission lines are not well maintained and there's things like trees that have fallen in the path, this can be really damaging in an event like a fire because the trees will catch on fire and therefore light the transmission lines. However, if these are well maintained, you're much less likely to have that problem. Continuing on, the next performance response consideration we'll look at is emergency response. So you can think about the types of things that could be put in place before an event like flooding, like sandbags alongside the road to make sure that the infrastructure isn't damaged and that the road is accessible. You could also go through and clear out culverts before a high water level event so that there's less debris and therefore able to carry more water. So for emergency response, we need to think not just about what you need to do, but who needs to do it and what do they need, and making sure that those plans are in place well before an event actually happens and everyone is able to mobilize quickly. With being able to mobilize quickly, something that can be very useful is having systems upstream of the dam that will let you know if you need to evacuate, so perhaps being able to predict this. You can see how for this community, the emergency response would be completely different if they had a few days to prepare versus a few hours, or even worse, no warning at all. We can also think about what could be done to prevent it from happening altogether. So being able to proactively lower the reservoir levels so that there's greater capacity, and then you may not need to evacuate at all. For energy distribution and generation, again, you would want to look at hardening or flood-proofing structures prior to flood events. For things like temperature, you also need to make sure that you consider staff safety. So if you have an extreme heat event that could be damaging the infrastructure, but your staff are not able to perform maintenance or things that are necessary at the time because it's unsafe to do that, what kinds of procedures do you have in place to keep them safe first and foremost? Look at the performance response consideration of policy. We can walk through some of the previous examples that we already discussed and see how these intersect. So for example, policy and design and functionality. We want to think about what types of design standards are already in place. So for example, if you're designing a dam, do you already know that you need to incorporate climate into the event and therefore perhaps look at larger flood events or higher water levels? If these standards are in place to begin with, it'll make your design and functionality stage much easier as you already know the types of things you have to look at. Looking at the example of policy and operations and maintenance, we talked about how you need to have frequent operation and maintenance along transmission lines so that things like trees do not get in the way and cause greater damage in the event of a fire. So a policy could explain who's going to do that, what types of resources they have available, how frequently does it need to be done, and what types of systems are put in place to monitor and make sure that this is happening. You can see how without a policy in place, it would be very easy for this to get pushed beyond what was possible or not be able to have accountability for who is responsible. Finally, we'll look at the combination of policy and emergency response. So when we talked about those examples of having early warning systems upstream to inform evacuation, who's responsible for doing that? Is there someone who actually goes into the individual community and provides warning to these people? What do they do? How frequently does it happen in advance of something like a flood event? And what types of resources are available? These are all things that you want to establish an emergency response plan well before you actually are dealing with some of these incidents themselves. So again, that plays into why if you have better policy in place or no policy in place, it will really inform how emergency response is possible in a specific event. So the purpose of this module was to walk through a structured way to think about how a system can be more or less sensitive and therefore could underperform or fail or be more resilient to climate impacts. So we just consider this one more way you can look at some of these very complex systems and break it down into more manageable pieces and better understand the types of risks that you'll experience. Thank you very much.